Good morning. Today we will discuss the regular expression and regular languages. First we will discuss the regular language. In automata theory, a regular language is a language that can be recognized by the finite automata. The basic definition of the regular language is a language that can be recognized by a deterministic finite automata or a non-deterministic finite automata. It can be expressed by a regular expression, deterministic finite automata or non-deterministic finite automata. See, this is regular expression. Basically, regular expression is used to represent the regular languages. In here, the regular expression are a way to describe patterns in strings using a formal language. In automata theory, regular expressions are used to define language accepted by a finite automata. We'll go to express the regular expression. In short terms, we can say that the regular expression is used to recognize the or express the languages. Number one. Number two, it accepts the finite automata. It will work. Some basic definition of this regular expressions is a regular expression, a string of symbols from an alphabet sigma combined using union, concatenation and clean concatenation and clean star can be expressed by the regular expression. Language, the set of strings that match given regular expressions. This pattern, a regular expression, that a string can be a string that is accepted by the regular expression. If the regular expression recognizing any string, that is known as a match. Acceptance, a finite automata accepts a string if it matches the regular expression. Means a finite automata, it can be a non-DFA or NFA also, both. A finite automata accepts a string if it matches the regular expression. The machine will accept the strings if the matches is done. Recognition, a finite automata recognizes a language if it accepts all strings in the language. Means it can recognize the things once it is accepting all the strings in the language. Rules for the regular expression, how we are designing the regular expressions is, the set of regular expression is defined by the following rules. Number one, you can see number one, every letter of sigma can be made into a regular expression. Null string, epsilon itself is a regular expression. Or this is also known as, if suppose there is two regular expressions, R1 and R2. R1 and R2 are two regular expressions. Then in brackets, R1 is a regular expression. R1 concatenation R2 is a regular expression. R1 plus R2 is a regular expression. R1 clean star is a regular expression. R1 clean closure, that is plus, is also a regular expression. They are all is a regular expression. It means that if R2 star is there R2 star, that will be a regular expression. R2 plus, that will be again a regular expression. So these are the regular expressions. For example, I have considered an example. Describe in language the set of represented by the following regular expressions. What they are giving is A in bracket A plus B star AB. So they are asking represent following regular expression. What they are representing? So they are representing means like the set of all strings starting with A and ending in AB. This is started with A because the string containing the value A. Second is A plus B. So we'll consider any value from this one, and this is A star. A plus B star. A plus B star means what is this? This is either we can take A, we can take B, we can take A plus B, A or A and B, no both, or we can start with a null value. If we suppose we start with a null value, the answer will be what? This will give you epsilon. This will be epsilon. And third is A and B. So the string will be A, B. Isn't it? This string will be generated. Suppose now I want to generate this string. How this will be generated? This is triple A. This is triple A double B AB. So how This is last AB is there, last AB is there, A is there. So we have to generate this double A B. This string need to be generated by A plus B, and this will be generated like, consider first A. This is A. Now this is A plus B star. So we'll take this double A double B from there, and the last one is AB. AB is compulsory. These two strings are these two. This is A plus B star AB. This string and this string is compulsory. They will definitely come. So this is generated like this. Suppose I want to generate this string AB. What will happen? AB. This is A will come. A will definitely come. And this is AB is there. AB is there. But we need only B. So we'll consider B from this side. So the string will come AB. Isn't it? Okay. Now come to the second point. This is A star B plus B star A. What they are generating? The string are either string of A followed by B, 1B. This is 1B, or this is 1B here. This is 1B. Okay, just wait. This is a hang. Sometimes it is happen. Okay, this is string. I have considered this string. This is AB, A star B plus B star A. This one. Now we have taken A star B plus B star A. Sorry, this is A. This is A. This will consider as A. Okay, just wait. This trying to write this. We will consider the second example. This one double A star B, B star A. So what kind of string this is expression is generating? Basically, see, this A star means A can be 0. Number of A can be 0, can be 1, can be 2, 3, 4, 5, any time. But there is only one B. In case of B star A, this is only one A, but number of B can be anyone. So what will happen? The string are the either strings of A followed by one B. Any number of a string of A, this can be A, B, or anything, isn't it? And this second one is generating B star A. This means generating B star A, number of B. It can be any number of B. This is any number of B. B can be 1, but must be a 1A. B can be any 0, so only one A will be there. Suppose B is 3 times B, so this will be generated by this. This kind of string is generated by A star plus B star A. So this is the final answer of this one. Now we'll go to the next slide. This is the identities related to the regular expression. So what is the meaning of identities? What is the meaning of this one? So this is saying that there is a number of rules here, and they are coming to the regular expression also. Given R, P, L, Q are regular expression, the following identities hold. What it holds? This phi star is epsilon is a regular expression. Sigma epsilon star is also a regular expression. This R multiplied by R, that is dot R star is equal to R star. R is a regular expression. Now here R star is equal to R star. This is equal, and this is a regular expression. R star in the bracket power of R star is equal to R star. This is also a regular expression. This is also a regular expression. R star into R. This is repeated. This is a regular expression. This is PQ star P is equal to PQP star is a regular expression. So similarly, these are the rules I have written. Suppose this is R plus R is equal to R will be a regular expression. Like R plus phi is equal to phi plus R is a regular expression. So every this is the total rules where the identity like give regular expression for all string concatenated containing exactly one A over sigma ABC. It is saying that we need the string which is made over A comma B comma C as input, but at least exactly containing exactly one A. There will be only one A must be required. So for this I have solved this example. So we can consider we have to find out the regular expression for all string containing the exactly one A. So this is the first case, we need only one A. Okay. Now, so what we have to remaining? This is for which we write the regular expression for any string all over the string sigma. This is which does not contain A, which is does not contain A. So the string will be any string. This is B plus C. This is star. This is this one. Except A, you just leave A. This is B plus C star is generating other strings except the word A. Now for exactly one A, what will happen? This is B plus C. Both the side the A can become B plus C can come. Suppose B A C. So how can we generate? This is generated by this is B plus by there. This is by this side, and C is generated by this. Suppose the string is generated like B C. One A is there A. This is again B C. So what will happen? This B C will generated by the B plus C star. This is one A. This is B plus C star. This string is generated by this one. This string is generated by this one. So go to the next slide. Next example is, we have taken the next example, given the regular expression for all the sets of the strings over 0, 1 beginning with 0, 0. They need the string with the starting with the 0, 0. So what will happen? This consecutive 0, this is 0, 0. For this we write the regular expression which represents the set of all strings over sigma is equal to 0, 1. That to all strings over the regular expression, over the given sigma, this is 0, 1 is this one. But what we need? We need they started by the 0, 0, value 0, 0. So we'll write this one. This is 0 is made by this. This is. Suppose we are generating written is here 000. So means what? This 00 will come exactly by this expression. This expression will generate 00, and this remaining part will generate the next part of 00. Because we are just first of all we have whenever we are going to make the answer, so we will take the conditions, what kind of conditions we have, and we have to apply the conditions. Here the condition is the string is started with the 0, 0. The string is started with 0, 0, so we will start the string with the 0, 0. Any string after this is 0 plus 1, any string we can consider. Okay, so this is happening. Now come to the example number 3 here. This is the determine all strings in, this is language is written L is equal to L A plus B star, this B bracket inside the bracket A plus AB star, this complete bracket is there, of length less than 4. We need the string whose length is less than 4. Means what? Any string having length is equal to 0 less than 4. So we can leave length is equal to 1, length is equal to 2, length is equal to 3. We cannot move for the length is equal to 4, 5. So but here the star is not there. The star is not there. So we cannot generate the string of length 1. Length 0, because we have the B in the middle of the word. So the length 0 will not come at any moment of time. So we will start with the length is equal to 1. So what will happen? Length 1. How this will come length 1? Length 1 will come like here. This is A plus B. This side gives 0 value. 0 value. and B, and the next side will give the again, this is A plus B star will give the 0 value. So this will be the answer is B. That's why the B is generated. Similarly, suppose we want to generate BAB. What will happen? So B will come from the first value. This will generate B. Next B is the compulsion. Sorry, this is generating BAB. BAB is generated by the B. This will give you the 0 value. B is generated by the B, and this last string AB is generated by here. This is AB. So the total string is BAB. Any of the string we can generate of the length 3. So number of lengths 3. Now we will consider this like example as we have taken. This is string. We have already generated B. Suppose we want to generate AB of length 2. Length 2. This will come from the A this side and the B from this one. This is AB generated. So we have to generate the total number of strings which the length is less than 4. How many strings we can generate? This is the number of strings we can generate using this one. So we have generated this one strings, and this you can work on this string. Okay. So now we'll go for the next slide. Oh, sorry. This is another example. Given a regular expression for the set of all strings over A comma B where with 3 consecutive B. This is another example where we are taking the 3 consecutive B in a sequence. So what will happen? This is total sigma is equal to here A comma B. So we can generate all strings we generated. This is A plus B and star. This can be generated. Here we have to 3 consecutive B we have to generate. So in 3 consecutive B, we will consider 3 consecutive B in between. This is B, B, B. This side we can generate anything. This side we can generate anything. Isn't it? This will generate any string to this one here. And from next side, this is again A plus B this star. This is generated. This will generate the difference. So this is the 3 consecutive we will consider. Okay. So now come to the next slide. We'll take another example like this one. The regular expression of all the sets, the strings over 0, 0, beginning with the 1 and ending with 0, 0. Here the problem is changed. What the condition is? So the first condition is the string will start with 1 and ending with 0, 0. Ending with 0, 0. Means we have the first starting point and the last point. So we'll consider the first point and the last point 0, 0. So what inside between these two strings, two strings will get the number of strings made by the 0 plus 1 number of strings. So this will be the right answer. This is 1 plus 0 or 0 plus 1 you can write a star double 0. Now come to the next example. This is regular expression for all strings over 0, 1 ending in either 0, 1, 0 or 0, 0, 1, 0. It is saying that the end point is clear. End point is clear. This is the end point. You can write combinedly the end point is written here. 0, 1, 0 plus 0, 0, 1, 0. End point, any one of these two will be the end point. And now, what will be the first point? The first starting point. The starting point will be the string made by the 0, 1. So we have considered this example. So 0 plus 1 star will be considered. So we can generate any string. Like suppose we want to generate from this one we have generated suppose 0, 0 and the ending point is 0, 1, 0, 0, 1, 0. So this string will be generated. This string will be generated. So similarly in this pattern we can generate the strings. So come to the next slide. And this is Arden's theorem. Arden's theorem will start the work on working on the Arden's theorem. Actually, what is the meaning of Arden's theorem? Why we are using the Arden's theorem? Arden's theorem is a theorem which is used to work over the regular expressions. This is a theorem basically if P and Q are two regular expressions over sigma, and if P does not contain epsilon, then the following equation in the R given by R is equal to Q plus RP. R is equal to QP star. He says that this is the format of the equation where P, Q, R, all three are in the regular expression. Then and the equation is in this format. Then this will generate the solution. R is equal to QP star directly. This is directly they can generate the solution for this equation expression. So using this Arden's theorem, we can construct the regular expression. We can construct the regular expression equivalent to the DFA and NFA. So next, for an example, now we have considered this example. So see, this is a very good example of this Arden's based on the Arden's theorem. This is DFA is given as construct a regular expression corresponding to the given finite automata. This is given. So we have, according to the Arden's theorem, we have to solve this problem. So what is the method to solve the Arden's theorem? So first of all, I will explain how we are solving this expression, this diagram. First of all, we will see number of states. So we will find there is two states, A and B, only two states. So it means we will generate only two equations. The number of states is equal to 2. So number of equations will be only two equations, one for A and one for B, isn't it? Now, the second is which one is the final state, which one is the initial state. If the final state is A, this is the A is the initial state. So we will write the equation for A. A is equal to, this is A, epsilon indicating the start. This is initial state, epsilon. We'll consider the number of edges coming from the which state it is coming. Now A, there is a self loop from the A to A. So we will write is capital A and a small a. A is the input, A is the state. Capital A is the state, small a is the input. It's coming from itself, loop. Now second incoming edge is this B. Coming from B, this is B and this is small b. It's coming with a small b. So this is the first equation. The second equation will be B is equal to, for B, this is B, this is B. Final state. But we will not write any epsilon or any value for the final state. We will write directly the incoming edges. The edges is coming at B is, first is this one. This one is coming A, B, A and B. Capital A and small b. Small b indicating the input. Now B. B is again looping itself. This is B, isn't it? Now we'll consider the equation, how this will work. See, according to the Arden's theorem, so what is the equation? R is equal to QP, Q plus RP, that is equal to R is equal to QP star. Suppose we are considering the first equation, so there is epsilon, so we will not consider that. First case. Equation 2, this is directly matching. Suppose this is B is equal to AB plus BA. If here we can consider AB, this AB is equal to Q. Suppose we will consider Q. And B is considered as a R. And A is considered as a P. So we can consider the equation directly, that is equal to answer that directly, that is R is equal to QP star. This is R is equal to Q P star. So here is Q is A, B and P is what? P is A star. So we'll write B is equal to A, B, A star directly, isn't it? The final state answer will receive. Now putting the value of this in equation 1. A is equal to epsilon plus AA plus BB. So what will happen? We'll put the value of B, this B. Instead of B, just representing this value. So what will happen? Epsilon AA in bracket is A plus B A star B. A is the common, so this will work like this. Again, comparing this equation with Arden's theorem. Again we are comparing this equation with Arden's theorem. So what will happen? This will be considered as a Q. And what will happen? This is R. This is considered as a R. And this is considered as a P. So what will be the answer? This is Q P star. So A is equal to R. This answer is Q P star. So what is Q here? Q is here epsilon. This is epsilon. What is P? P is equal to A plus B, A star plus B. This is A plus B, A star plus B. So this answer A, for the A will get this answer. This is A is equal to A plus B, A star B and complete star. This is complete star. Now putting the value of A into B to get the B free from the states. This is B. How we are getting it? This is B is equal to A, B, A star. So putting the value of A. This is the value of A. This is putting the value of A. This is the answer will come. This is A plus B, A star. This is A star. Bracket B star B A star. So this is final answer. So we'll get both the value. We receive both the value A as well as B in terms of inputs. Now come to the next slide. Again I am going to solve an example with this example 2. This is now we are going to solve the second example. This is based on the Arden's theorem. Now this is the equation. There is a number of states is equal to 3. This is Q1, Q2, Q3. We have 3 states. So we will construct the number of equation 3. 3 number of equation we will construct. Okay. So what will be the equations? These equations will be at Q1. What will write on Q1? Suppose we started with the Q1. This is Q1 here. Again, this is Q1 is equal to. So Q1 is the initial state. So we'll write this epsilon plus self value. This is Q1 A plus any incoming as this coming from Q3. This is Q3 A. Or is this coming from Q2 also? No, this is not coming from the Q2. So this is okay. This is equation 1. Now come to the equation 2. This is right equation 2. Now add Q2. This is coming from Q1. Is this coming from Q1? This is Q1B plus itself. This is Q2B. And any S, it's coming from Q3 also. Q3B. Okay. This is Q3B. This is number 2. So third equation will be Q3. Q3 is equal to Q3 is equal to number of S is coming inside this. This is from A. This no S is coming from B. Is coming. This is Q2 A. Q3 no. This no S is coming. This only 3 equation is there to solve this purpose. Solve this equation. Now come to the next slide. This is this is the 3 equations we have written here. 3 Q1, Q1A, Q3A, epsilon, Q2, QB, all B, Q2. So how do we solve it? First, I will show where I can apply the Arden's theorem and we'll get the possible solution in a very short term. So we'll start with suppose we have started with the Q3. This is your number 2 equation, this is your number 3 equation, this is your number 1 equation. So we'll start from the Q2. This Q2 is equal to Q1B plus Q2B plus Q3B. And now we know that is Q3 is equal to Q2A. So we'll put the value of Q3 here, this Q2A. So what will happen? What will be the value? Q1B, Q2B plus Q2A, B. This. So we'll take the Q2 as a B as a back. So what will be the answer? This is B plus AB. Now Q1B plus Q2 plus bracket inside bracket B plus AB. Applying the Arden's theorem here, if apply the we will apply the Arden's theorem in this way. So what will happen? This is R. This part indicate the. This is R. This is your Q part. This is your P part. P part. So the answer will be QP star. QP star. So what will be the answer? Q is Q1B. This is Q1B. Okay. P. What is P? This is B plus AB star. So this will be the answer for what? For Q2. QT is equal to R. So QT will be, this is the answer. So now go to the next slide. This is okay. Now this is Q1. So we are taking the value of Q1. Q1A plus Q2A, Q3A plus epsilon. What is happening here? This is Q1A is okay. There is no change. Q3A. This is just putting the value of Q3. This is equal to Q2A. Q3A is equal to Q2 is equal to Q2A. So putting the value of Q2A here, and this is epsilon. Just before this slide, we got the value of Q2. We received the value of Q2 in terms of Q1. So we are putting the value of Q2 in terms of Q1 here. This is the value. And double A plus epsilon. This is substituting the value of Q2. So what will happen? This is again, this is Q. Answer will be, we're going to solve it. We'll take the Q1 as a common factor. This is A. This is Q1 is common. B. And in bracket, inside the bracket, this is an A star plus epsilon will come. Now, just see the answer. Suppose this is your Q1. This is the Q1, final Q1. Now we want to apply the Arden's theorem. We want to compare this by the Arden's theorem. So what will happen? This will represent the value of Q, and this will represent the value of R. So this remaining value will be represented by P. P. So the answer is QP star. QP star. Q is epsilon. This is epsilon. P is, this is the complete value is the P from here to here. This is written here, and the star. I am putting the star. Epsilon will represent the epsilon. The answer is equal to directly A. This is the answer. This is your Q1. Now, this is hence the regular expression is, this is the regular expression. Now, go to the next slide. No. This is again some different questions like construct transition system equivalent to the RA A plus B star AB. This is the, so we have to design. So what is happening here? So this is the process. This is the answer basically. We have designed here, but I will going to explain it. This is, first of all, this is the string that I have to. That for this purpose we have to generate the transition system. So we take the two states, initial state and the final state. This is our initial state and this is final state. Okay, inside the state we'll put the value of this input string. This is the input string. A, inside the bracket, this is the complete string is put. So how we can generate this line, next line. This is the separate string, this is the another separate string, this is the A comma, this is the B. This is means we can change the state. Suppose the first string getting Q1, Q0 getting A, after that is reaching to some state. We have currently we have considered it Q1. This is taken as a Q1. Now after Q1, this string will come. This is coming. Now this is reaching to Q2 state. Again this A will come, yeah, of course A is coming. This is reaching to the Q3 state. Now B is coming, this is B, this is Q1. Final state is I have. Okay. So we have just distributed in a single loop, in a single token. Now this is the single, this is single, this is single, but this is not single. A plus B star is not single. For this, what is this? Whenever we are generating the string like Q1 and there is Q2, and inside this is A plus B star. So we will generate here this one and this side epsilon value, and we will generate this is A comma B. This is the process to generate this star. Star means the loop, the self loop containing the self loop. Star means there is no, maybe a null value, So we are taking the null value on both the sides. We are taking the loop. So we have generated, this is Q1, Q2. Inside this we have generated the Q4. This is Q1. Start from the Q1. Go to the This will go to the Q4, and this Q4 will reach to the Q2. This is A. This is your Q2. Right? So this is the final answer. This is first state is Q1, Q0. Second state is Q1, then Q4, Q2, Q3, Q2. This is the finally generated by this string. Now coming to the next slide. This is again the same kind of question, but the pattern is different. This is A, B plus A star. Second one is the A plus B. So we'll take the two states, initial state and the final state. Initial state and the final state. Okay. We'll divide this string in the two parts. This is first one, this one, A star this side and AB is this side. Okay. This is divided in the two parts. This we've taken the in middle, we've taken the Q1. Now again this AB plus A star. AB plus A star. Just previously I have told you, this is epsilon will come in both the sides of the string. Okay. And then this will generate the loop. This is generating the loop. AB plus A star. Okay. Now this is clear till A. Now this part is double A plus B. What is happening here? Double A. A. This is A, and A is again coming A. Two linear execution of A, then again A. Two in between there is a state A, and the next state A. It is reaches to the final state. Okay. And if there is a two path, basically there is a two path. One path is following with the AA, second path is followed by the B only. If the B is coming, it reaches directly to the final state. Now, this is perfectly alright. We have to work on this part. This is AB plus A. AB plus A. AB means this is AB. AB means it is A and B both. This is going to A path, then coming back to B path. This is coming back to B path. So what will happen? This is we have taken another state A1, A going to A with A and coming back to B on the same state. Coming to the same state because the value is the same. Cannot change. And this A is the self loop. So this is the final representation of transistor system equivalent to the given regular expression. Now this is thank you for the patience.